Hi, David's my name, and I'll be taking you through this fundamental module on pull-up and pull-down circuits. Control modules have signal inputs, and most of these signal inputs go to either pull-up or pull-down circuits. We're going to be having a look at three types today. We'll be looking at digital or discrete two-wire circuits, analog two-wire circuits, and analog three-wire circuits. There's also digital three-wire circuits, but we won't be having a look at those today. Let's go over to the diagram and have a look at our first circuit. This is a diagram of a pull-up circuit with a digital signal. The digital signal is purely a switch that is either on or off, hence the term digital. We'll have a closer look at what is meant by a pull-up circuit. You can see inside the control module here we have a voltage at the top, and that's normally 5 volts. We have a pull-up resistor. We also have a monitored or signal point. That's the point where the control module itself monitors the signal that's coming in. When we exit the control module, we've got our sensor. In this case, as I said, it's simply a switch. And it will now go back to a ground, and that will either be inside the module or it could be just attached to the vehicle somewhere. What happens when the circuit operates? With the switch open, the signal or monitored point will see 5 volts. When we close the switch, we now have a ground path to that signal point, and it will go to 0 volts. And that's how a module knows when a switch has been activated. It is constantly watching that point, and when it goes from 5 volts to 0 volts, it knows that switch has been activated. Let's go and have a look at this on one of our circuits. Here we can see a 2-wire digital pull-up circuit mounted on our circuit board. We've got 5 volts at the top and a ground at the bottom. This is being supplied from our power supply, but would normally be supplied from within the module itself. The 5 volts is a reference voltage. That means that it doesn't change. Regardless of what battery voltage does, this remains at 5 volts. We also have a pull-up resistor and a monitored point where the module receives the information from the sensor. Our switch down here is our sensor. It's a simple on-off sensor, in other words, a digital sensor. You'll notice that the voltage at the moment on our multimeter is 5 volts. That means that the switch must be in the off position. If I turn it on, you'll see the voltage immediately drops to 0 volts. That's an indication to the module that the switch has been turned on. The module can now take whatever action necessary to complete that task. If I turn the switch back off again, you'll see that the voltage goes back to 5 volts. Common uses of these circuits are hatchback releases, boot releases, and some seatbelt reminder circuits. In this diagram we see a 2-wire digital pull-down circuit. Straight away we can notice the differences between this and the previous circuit. We still have a resistor, but in this case it's connected to ground rather than a voltage, so it's a pull-down resistor. We have a monitored or signal point, and on the outside of the module we still have our sensor, and again this time it's a switch. The other side of the switch goes back into the module where we have 5 volt reference. The operation of this circuit is when the switch is open, we will get 0 volts at the monitored point. We get that through the pull-down resistor from the ground inside the module. When we close the switch, 5 volts is applied to the monitored circuit, so therefore our voltage goes from 0 to 5 volts. Again, the module now senses this voltage change and can now act upon it. And here we have our digital 2-wire pull-down circuit on our circuit board. This time the control module's down the bottom and the vehicle's up the top. But we still have our 5 volts, we still have our ground, signal point, pull-down resistor, and our sensor. But you'll notice this time with the switch open or turned off, we have 0 volts on our multimeter. If I now turn the switch on, that will now go to 5 volts. So it's the exact opposite to what a pull-up circuit did. These circuits can be used in similar places to pull-up circuits, but the one we're about to have a look at on a vehicle is a pull-down circuit which is used in a door lock release circuit. We'll go out and have a look at it now. Now that we've had a look at both digital circuits, both pull up and pull down, let's see how they behave on a vehicle. I've got my scan tool hooked up, the ignition's turned on, and we've got it in graph display. What we're doing is we're graphing the unlock switch in the vehicle. If we operate that a few times, you can see each time that the switch is activated, we get a 5-volt pulse. And if we hold it on, you can see it remains at 5 volts while that switch is turned on. So this must be a pull-down circuit. It's normally at 0 volts, and when we operate the switch, it goes to 5 volts. In our next diagram here, we can see another 2-wire pull-up circuit. It's exactly the same construction as it was in the first circuit, but this time the sensor is different. Instead of being a discrete or a digital sensor, it is now an analog sensor. In other words, its resistance changes with its environment. This one here is an engine coolant temperature sensor, so as the engine coolant changes temperature, the voltage at our sensor point will also change. Here we can see the diagram we just looked at built onto our circuit board. It's exactly the same as our 2-wire digital pull-up circuit, except that our sensor is now different. Instead of being a digital sensor, it's now analog. And if we watch the meter, we can see that the fully anti-clockwise, we have a reading of 1.91 volts. And if I go fully clockwise, I go to 0 volts. So that's the range of this particular sensor. So what it's doing is sending an analog signal. Now the module has to have an analog to digital converter built into it so that it can interpret these analog readings as a digital readout. In this diagram we can see a 2-wire analog pull-down circuit. The circuit is exactly the same as the digital pull-down circuit except for the sensor. This sensor supplies an analog signal just like our 2-wire analog pull-up circuit, but the voltage readings will be the exact opposite, as we can see here. So that's analog pull-up and pull-down circuits. We'll have a look at one on the car. This time we're going to have a look at an engine coolant temperature sensor. Again, I've got it graphed up here on the scan tool, and what we'll do is we'll start the engine up. Now we'll turn the engine off. We can see by looking at the screen that what's happening is the engine coolant temperature is increasing very slowly. As I mentioned before, this is a pull-up circuit. And what's happening is the resistance of the engine coolant temperature sensor is changing, and that's affecting the voltage signal that's going into the module. Let's have a look at 3-wire pull-up circuits. We have a pull-up resistor, which goes up to a 5-volt reference. We have a signal point, and that's where the information goes into our module. And we have a signal wire, which goes down to our 3-wire sensor. A 3-wire sensor can give a lot more information because each side of the sensor is connected to ground and 5 volts respectively. So the signal can vary between 0 and 5 volts. And here's our 3-wire analog pull-up circuit. 5-volt reference, our ground, our signal point. We now have a pull-up resistor in here, and our potentiometer is our sensor. If I rotate the potentiometer completely clockwise, you can see I'm going to get 5 volts. And if I rotate it completely anti-clockwise, I'm going to go down to 0 volts. So now the sensor is capable of measuring anything between 0 and 5 volts, and this makes it a very useful type of sensor, commonly used in accelerator pedal position sensors. As we can see in our last diagram here, this is a 3-wire pull-down circuit. The only difference this time is that the resistor is connected to ground and not 5 volts. And that's the only difference between a 3-wire analog pull-up circuit and a pull-down circuit. Okay, here's our 3-wire analog pull-down circuit. You can see the only difference between this and the last circuit we looked at was the positioning of the resistor. It's now on the negative side rather than the positive side. What difference does that make? Well, let's have a look. If I turn the control completely clockwise, right, we have a variable resistor, we get 5 volts. If I turn it completely anti-clockwise, I get 0 volts. Exactly the same readings I got with the pull-up circuit. The first pull-up and pull-down circuits reversed their readings. The second one also reversed their readings, but this one doesn't. The only way to get this circuit to reverse its reading is to change the positive and negative side of the potentiometer or the variable resistor, and they do that in some accelerator pedal position sensors, where one will go from a low voltage to a high voltage and the other one will go from a high voltage to a low voltage with the same movement of the accelerator pedal. So you can see this can cause a bit of confusion. It's the connection of the 3-wire sensor that makes the difference, not whether it's a pull-up or pull-down circuit. Let's go out to the vehicle and have a look at one of these sensors. And that's 3-wire analog pull-up and pull-down circuits. The most common of these in a modern vehicle is our accelerator pedal position sensor. We've got our scan tool hooked up here to register our pedal position values, and what we're going to do is we're going to operate the pedal a couple of times quickly and then slowly open it and slowly close it, and we'll see what results we get. So we can see here the 2 snap openings of the accelerator pedal, and now we have a slow opening and a slow close. Even though we don't see the voltage, we still see the effects of what the sensor is doing. It's actually sending a change of resistance into our pull-up or pull-down circuit, and that is now being interpreted by the module as a percentage value from 0 to 100%. And that brings us to the end of our module on pull-up and pull-down circuits. We've looked at 3 different types. We've looked at digital 2-wire, analog 2-wire, and analog 3-wire. This should help you with your diagnostics. Remember, if we know how something works, we can always diagnose it easier. And also remember that with today's technology, training is your key to success. Bye for now.